structure with medium to hard soil, or sometimes very a big stiffness. Since its natural frequency is inherently higher, resulting a higher seismic force working on structure. LRB with work besides LRB will make the natural period longer. It also make damper, which will be reduce the earthquake load. And forces working during surface conditions such as continuous structure. LUD will redistribute all act as when there are very quick velocity, the LRB will work, and the quick velocity is always done by earthquake. But if just only for the creep, shrinkage, and temperature, LUD will be moved slowly, not very straight, and not has the very big tension or compression for the structure. Thank you for listening. Assalamualaikum warahmatullahi wabarakatuh.
And time what like you have. Thank you very much. And then, ladies and gentlemen, we will continue to our presentation today. On the last presentation, likely will be presented by Suprapto or anyway. Are you ready?
Yes, sir.
You have 20 minutes.
Yes, sir. Yes, sir. Yeah.
Okay, starting from now for 38. Okay,
Thank you, Prof. Widodo. Assalamualaikum warahmatullahi wabarakatuh. And I'm sorry, Prof. Widodo, that I will be able to be there in the event to accompany you because of my situation. I have easy since this morning. Yeah. And ladies and gentlemen, my presentation actually a kind of a resume note of our field study in many civil engineer gathering. So I think so we all familiar with the topic. Starting from the earthquake in Jogja, the impact of earthquake on the community, since in only split seconds, yeah, situation becomes so chaotic and very little. And from the day one of the event, we have been in the field to do what we can do, to learn what we can learn, and it was a huge experience. Since then, we try to do the time and we are or from local government. Yeah, we visited the disaster area together. We observed as well as on how to mitigate there. So this paper is kind of a resume of our journey on learning about the earthquake disaster and hoping that we can learn on how to deal with it, especially for the non-engineered buildings, along with all my colleagues from many universities, as written here. In Jogja, in So this event is kind of evident that that is real. Friction is one of the key factors in earthquake disaster mitigations. And this data has also been, we also learned that the most common structural system.
Slide is not moving still.
Oh no, I already moved to the second slide.
As the committee to give sign next and next and next and so on and so on, because your slide right now is still the first slide.
Now I operated by on slide, Prof. Let me see, let me
Okay,
let me
let's
stop and then I'm trying. Yeah. How about this?
it's okay.
Let's put it. Yeah, sorry for that. Yeah. I continue my presentation. Then we also learned that the most common structural system of non-engineered building in Indonesia is masonry, especially brick masonry structure. Yeah. We also know that the characteristic of masonry structure is brittle. Yeah. In order to make earthquake resistant, it should have sufficient ductility, and then a concrete to add it a characteristic for adding the ductility. Yeah. And there is specific detailing on how to make the masonry system to also already stipulated in the guideline in many lesson report, as well as already stated in the standard. Yeah, it's mean that in terms of technical documents, we already prepared. Yeah, we already prepared, and this is many document. Yeah, many other available online. Yeah, and these documents are available in the either in the hard copy or even in soft copy. This material are available on. It can be downloaded everywhere, anywhere, anytime, and free. So it is accessible. Yeah, accessible. But what happened in the reality? Yeah, they were reported in many earthquake area, many non-engineered buildings were collapsed. Yeah. Even for instance, in January 2002, yeah, it was reported to damage about more than 3,000 houses and injured about 10 people. Yeah. While we back in 2011, yeah, the 7 Richter scale earthquake has caused more than 30,000 houses collapse and or damage, and caused more than 500 deaths. And on September 2009, the 7.6 Richter scale earthquake has caused 270 house building damage or even collapse, and more than 1,000 deaths. Yeah. So it is very, very little. Yeah. Now let's see about the seismic resident design consider two main conceptual aspects of design in seismic event, namely strength and the building's ductility to avoid sudden collapse, and also prevent to be avoided to experience sudden collapse. Should be avoided to experience sudden collapse. Field evidence show that most of the victims of the earthquake took place because from the collapsed building. And now we have the technical specification on how to make the non-engineered building to be earthquake resistant here. However, conceptual design alone will not guarantee that the building will perform as expected. Good construction practice also play a significant impact on building behavior under earthquakes. From field observation, we learn of non-engineered building comprises of four aspects, namely good quality of material, good technical detail, appropriate lateral strength, and proper ductility. Field observation, we assume that the typical damage of non-structural building are caused by four major aspects. One is in-plane and out-plane failure of wall. It because of low quality of brick or mortar or lack of concrete confinement. The second is inadequate or improper steel reinforcement. Usually it's caused by incomplete concrete confinement or poor steel detailing, for instance, undersized or improper steel splices. And third, because of the wall opening for door or window, which is too large and also without proper concrete confinement. And the third is poor quality of material, bad quality of masonry and bad quality of concrete as frame skeleton of masonry wall. And the fourth is poor structural design. For instance, large opening or long wall without lateral support, lack of lateral on how it affects the value condition of every on only one cause of damage of the building, since most of the damage building resulted from complex interaction. So it's not easy that to find only a single cause. Caused by many factors that brick masonry also experience partially collapse of wall and excessive skeleton. And the next picture also show the same situation. The second condition, second factor about inadequate or improper or none of steel reinforcement also shown in this picture. So all of these pictures are found in many disaster earthquake area. So it's not come from one area; it's come from many different areas. So it's been kind of typical damage that we observe from many disaster area. And the third is about the poor quality of material. We can see here how the collapse of the wall. So how poor the wall is. And in this right picture from here in the broken here, we can see how how bad is the quality of the concrete. Yeah. So it's so that the bond between the concrete and the steel are so low. Yeah, so low. Yeah. Again, the similar situation also shown in the pictures. And then here, a poor structural design. Disaster area, many houses, yeah, that are supported only by frame skeleton. Yeah. But the frame skeleton, the quality is very poor, very poor. So it seemed that the builder they did not consider about the lateral strength that needed to support if there is a earthquake struck in the area. And also we also find that many two-story building, especially those buildings that are used for ruko, yeah, this for resident as well as for business. Yeah. Usually, the first floor are for business purpose and second floor is for resident. Yeah. Because of the business purpose, usually one of the side has a lack of a wall. Yeah, and walls serve as the stiffness, lateral stiffness. So the absence of wall make it very weak against horizontal forces such as earthquake. Yeah. So let's come to the discussion. Yeah. So the field we can state here that the non-engineered building will suffer damage due to lack of proper design, lack of technical control, and supervision during construction. This is also similar finding and attention resulting from lesson learned of previous earthquake in many countries. Yeah. The second, the execution of the construction work for most non-engineered building was carried out solely by mason. Yeah. As the name of non-engineered building means that the involvement of engineer is very few, very weak, very less. Yeah. So the quality of construction will rely on the skill of the mason. Yeah,
presentation. Okay.
Yes, thank you. Therefore, in order to improve the quality of structure, mason skill improvement on housing technicalities is necessary. Then, improving technical skill would be meaningless without strong commitment in adopting proper construction practices. Therefore, it is also deemed necessary to encourage better commitment for any person or parties involved in construction practice toward guideline or any other specification. And then the fact that construction standard, guidelines, as well as report on lesson learned are widely available as well as easily accessible for community, mean that the need for earthquake safer house as consequences of living in disaster-prone area has not been the main interest for the community. There is a need to further strengthen disaster management program aiming for preparedness, mitigation, as well as prevention. I think my point is here that it seems that although we learn that we are living in the disaster-prone area, but it seems that the awareness of the people to have a safer house toward earthquake is not the main interest. That main topic that we are going to share with you. And for this paper, we conclude that based on the finding and discussions, several conclusions will be done as follow. Yeah. First, the damage structure of non-engineered was due mainly to the poor construction practices. Yeah. Second, the quality of non-engineered houses relies on the technical skill of masons. Third, The poor quality of non-engineer reflect the need of safer house to earthquake have not been the main concern for the community. So, as a consequence, there's a need to further strengthen to earthquake disaster mitigation program into the society. I think that's all our presentation, Prof. Widodo, and I conclude the presentation. Thank you very much.
Thank you, Pak Prapto. Actually, you still have 2 minutes for your presentation, but anyway, thank you very much. Okay, ladies and gentlemen, now we come to the discussion. Like I was mentioned before, that we have 20 minutes for our discussion. If you have any question, comment, clarification, correction, or suggestion, and don't forget, please mention to whom your question is addressed to. Okay. Starting from right now, please raise your hand, or please maybe we can detect by using chat, if you have already written in the chat. But anyway, okay. Okay, please. Okay. Any other comment, question, suggestion? Okay, please, guys. Don't forget to mention to whom your question is addressed to. Okay.
Thank you, Prof, for the opportunity given to me to give a question. For my first question, I want to ask the second presenter. Sorry, I forget the name, but maybe to the second presenter. Because I see in the presentation, when they measure the frequency or another in the bridge, the arch bridge, if I don't wrong, I saw that the measure is only located in the arch segment of the bridge, but I don't see the measurement is located in the strike segment of the bridge when they are testing the bridge frequency and the other. So the first question is the strike segment of the bridge is also influenced to the arch segment of the bridge. And the second, how about the measure of the number of the total of the testing location? The total of the testing location is determined statistically, statistic, or it only depend to the availability of the measurement devices. It is my question to the second presenter. There are two questions.
Yeah. Okay. Hello, Pak Budi. Can you hear the question, Pak Budi? Hello, Pak Budi. Pak Budi in the second presenter. Hello, Pak Budi. Can you hear my voice?
Pak Budi atau Pak Hari, Pak?
Pak Hari atau Pak Budi? Okay. Can you hear my voice, Pak Budi, Pak Hari?
Okay. Allow me to continue my question to the second to the Mr. Sprapto, the last presenter.
Okay.
Yes. For Mr. Suprapto, I ever read the standard. If I don't wrong, it is the standard published by the Ministry of Public Work and Housing. In the standard, they have made a limitation of the area of the masonry wall, which can resist the earthquake load. If I don't wrong, the limitation of the masonry, if it is a range less than 20 square meter, and if reinforced with the wood frame is less than 16 square meters, if I don't wrong. But my question is this requirement is still relevant to apply in our structure design to resist the earthquake load according to nowadays condition? Maybe that's only my question to Mr. Suprapto, the last presenter. Thank you.
Pak Suprapto, can you hear his question?
Hello, Pak. Yes, Prof. Yeah.
Okay, can you hear his question? Can you?
Yes. Yeah.
Okay.
Yeah. Thank you, Pak Toto, for you.
Okay.
You are welcome, Mr.
Okay. Still other for this discussion, question, comment?
Prof. Vito, can I raise a question as well?
Okay. Okay.
Yeah, because I think the topic is very interesting for me. Yeah, just similar to Pak Topo, I interested in the paper, the presentation from the second presenter from Pak Kadri and Pak Ari Pramudito. Yeah, my question is about the creep. Yeah, creep. Yeah, because creep is affect especially for the heavy structure, especially for long span concrete structure. Usually creep play main role. So my question is there any?
Pak Prato, likely Pak Budi and Pak Ari already gone, it's not around.
Okay, yeah, okay, that's okay. That's
respond,
But Pak Ari Pramudito is still online, Pak. Yeah.
Hello, Pak Ari, can you hear my voice?
Yes. I can hear the question.
Yes, there. Okay, please continue.
So my question is, is there any plan to do the same test at regular time? Yeah, at regular basis to find out about the creep, because creep is affect the long-term characteristic of the concrete bridge. Yeah, so it's not only this time of test, but maybe the next test after several years or something like that. Is there any plan to do that? Yeah. Thank you. That's all about Prof. Toto.
Okay, thank you very much, ladies and gentlemen, because our time is very limited. Riviana to answer his question.
Okay, thank you very much for the question. So the code for the seismic isolator or seismic device, we still use EN or ASTO, but based on consensus KKJTJ, Komite Keselamatan Jembatan dan Terowongan Jalan, it's also based on this one EN or ASTO. Especially for the prototype test, we should use EN because ASTO is not too detailed. But EN code is quite detailed for to guide our prototype test. But Indonesia itself has the own code for this kind of seismic isolator. We still research for this one, and as until today we use for EN and ASTO for that one. For the second question, I'm sorry, not quite clear for that one. Yeah. We always give them such kind of metrics, so we can give them a suggestion, but we always give them also the recommendation, because the owner sometimes LRB is still from the import or something and so on, but so I have to give them another alternative for the design, and they can choose which one they want to apply. Thank you.
Okay, thank you very much, Ibu and Pak Prapto. You have one question from the audience. Can you?
Yes, Prof. Yeah, Prof. Yeah. About the limitation of maximum wall confinement of about 20 meters square. I think, as far as I understand, the limitation is not only it's not 20 meters square, but only 10 meters square. Yeah, it's to deal with the outplane or outplane bending, not in the in-plane bending. Yeah, I witnessed myself that and in many earthquake area where the concrete confinement is more than is too large, more than 10 meters square. Yeah, we can see that many wall are broken. Yeah, are broken. Yeah, and so I think it's still relevant for the code now, Pak Topo. Yeah, thank you very much. I think that's my answer, Prof. Widodo. Thank you.
Pak Budi and Pak Pramudito. Hello, Pak Budi and Pak Pramudito. Can you hear my voice? Hello? Hello? Pak Budi, Pak Pramudito, Pak Ari?
Oh, okay.
Question,
Just
please.
yeah.
Your time.
I think the question about the creep monitoring for the in situ analysis for the in situ monitoring for creep for the bridge. Okay. So actually for this kind of technology, we haven't used any kind of this one on the Indonesian bridge especially. So, but on the we can know that every business bridge for especially like a Kuningan on the balance cantilever has a big effect on the creep shrinkage. So the based on the monitoring for creep usually is based on displacement or vertical displacement. So it can be measuring using the permanent measurement for the verticality using laser or something that maybe from optical like permanent RTS using a GPS sensor. I think it's quite new, but it can be monitored using for dynamic. I think it's quite difficult to compare to the dynamic characteristic. So basically, can be measured by only by this my answer for this one.
That's my question, Pak Ari. Because creep cause the addition of deflection. So the additional deflection will cause different dynamic characteristics. So is there any plan to do the same test, the same dynamic test in different time period? For instance, in 5 years or in every 10 years, to see the effect of the creep. I think that's my main question. Yeah, thank you.
Okay. Basically, we have been contacted by the commission of the safety or the contractor or the owner of this project for measuring the creep of this long span bit of the LRT. And maybe we have also contacted for the SMS for any kind of discount for the checking the creep displacement monitoring for years after years. So basically, creep should be monitoring for several years continue continually in community. So I think his position is in the large or the I mean the in the I mean the continue is very long time. I think it's not so important for measurement until there is some kind of the big displacement. Then it should be monitoring day by day or the year by year. So for the meantime, now we haven't seen any proposal for checking the. This is my answer.
Thank you. Thank you.
Hello. Hello, ladies and gentlemen who still attend through online or attend in this room. We still have approximately 8 minutes. So if you still have any question, clarification, or suggestion, or anything else, please. Hello. Any other question, clarification, suggestion? Okay. Okay, Ibu.
Izin Pak Ari, saya nambahin sedikit. Tadi Bapak juga ada pertanyaan terkait dengan position of the sensor ya. Oke. Ya, Pak Ari tadi ada pertanyaan. There's a question about the position, the number of the sensor. Let me answer for that question. Okay. So the number and the position of the sensor is based on the designer suggestion, because the designer always know where is the sensitive area which is can give the excitation, give the result for the small excitation or even bigger excitation. So the tester always coordinate with the designer which place should be give the sensor and what kind of the sensor type to the put in here. So they have to coordinate with the designer. And for the creep, actually we have already asked for put the string gauge along the bridge line. So it can be also detect the strain due to the creep, because the long-term creep shrinkage we consider about 50,000 days, and the effect for the creep shrinkage actually quite big, especially if we do not consider about the time due to the closure. So when the LRT go through the cantilever, actually the creep is very small, but after it closed, the long-term creep shrinkage is quite big, and will be for the strain. So the sensor should be put in here, put in there. That's the strain gauge, and I suggest to put it at the near the peer head, which is have a very quite big for strain due to the creep.
Thank you, Bu. Thank you.
Actually, we still have 5 minutes more. Okay, you still have any question. Okay. Anyway, if you don't have any question, I think I have right as well, to ask a question. Okay. I think from the presenter number 1, Bapak Enggar Tiarso Lintang. Pak Lintang, are you still monitor? Halo, Pak Lintang? Okay, do you hear my voice, Pak Lintang? Okay. And then, okay, Pak Budi and Pak Ari. Pak Ari, I think you use eccentric mass shaker. I think this device is very good in computing the structural damping. Is that right, Pak Budi?
For damping, we have checked for generating the like a guitar. So if the shaker have same frequency as the bridge will be shaking also. So basically, it's just for the checking the frequency of the bridge using the same amplitude, or sorry, the same frequency, and the bridge will be acting if the same frequency taken will be, the bridge will be shaken at the same time. So not for the damping. The damping can be seen by impulse. So the impulse generating the impulse, and we can see the damping. But for the eccentric mass, we just only see the eigenvalue.
But if not, I missed I said to record the displacement history. So that's why the displacement history. That's where you able to
the eccentric mass will be generating the force. So it's continue. The force will be continue in the same way that it will reach it, and the frequency that for the minimum and the maximum. So if we can see the damping, if the force is just impulsive, and we can see it will be disappear in the time dimension and the time unit. So if you check here, it will the unit will be shaking until it stop. So the damping is, I think, is not very can be seen, but it must be it's clear then if you just use the impulse, because the impulse is the force in the time period is very significant. But in the we use eccentric mass shaker, it just continue to shake until it stops. So the time period is not very can be seen in the exactly way. It's better that we use the impulse for the damping.
Okay, thank you very much, Pak Ari.
Yeah.
The third question to Ibu is addressed to Ibu Deli Triana. Ibu, in your model, you just consider horizontal spring and also rocking spring. Why you didn't include horizontal damper, vertical spring, vertical damper, and rocking damper? Because it will be very important for dynamic analysis. Oh, simplification. Yeah. Okay. And then the last question is addressed to Pak Prapto, and I think similar to the first presentation, because we still found so many structural damage under earthquake, and then the result according to presenter that poor material quality, poor structural design, and so on and so on. As we know that our design code, our loading code, either gravitational or earthquake load, already regularly updated. I think the code already no problem anymore. But why we can found in the field that so many structures still damaged under earthquake? So my question is, what's really the root of the problem in the field? Because the code it doesn't any problem anymore because it's already regularly updated. Pak Prapto, can you do you have any